Okay, so I'm going to give you an insight into how to do some really complex queries. We're going to do a couple different ones here. We're going to be getting some information to be able to display this table here. This is a JQ grid. You can check it out here. Here's the grid API. We're going to kind of export some data from the SQL query. So we want to know and these are apps by a developer. That's what this category is. We want to know the ID of the app, the name of the app, the number of views the app has had, the download count, the sales count, the donations count, every unique customer, because a customer can download it twice, and the royalty due. Okay, that's what we want to know from this data. So in this, we're going to learn how to do joins, left joins in per se. We're going to learn what group by is. We're going to learn how to do counts, sum, and even count distinct, all in the same line. Okay, we're also going to be able to do some math right in the query in case we need to. So let's get started writing the query. I'm going to let you know the tables that we're going to need. The admin table has information about developers. That's actually the developers table, it's not renamed. Customers table has information about customers. We've got the orders table, which has information about an order. The orders products table, which actually has information about an order per product. Okay, so this ties to the products table, which is right here. Here's the products table, which has ties to the product description table because there's not all the information that we need, okay, in the products table. Some of that information is in the products description table. Okay, so that's how those relationships work, and we're going to form those here. Okay, so the first thing we want is the ID of the app. So we're going to say select, and what do we want to get? Well, we want to get the app ID, which is in this case a products underscore ID. Okay, and that's going to be products underscore ID from the products table. Okay, and we're going to say where. Okay, so now we want to exclusively say where, and in the products table there's a field called owner, so products dot products owner. Okay, now if you're used to writing SQL and you're not used to having this dot here, the dot is there because we're going to have lots of joins in this statement, and if you have two tables that you're joining together that have the same name, such as their ID that you're joining on, that will be called ambiguous, and SQL will throw an error. I'll explain that more in a second, but just know products.productsOwner. And you know what? Let's do that in a second. Anyway, we'll just do it products owner. Okay? And that's going to say products owner equals, and we're just going to use a test number here of a developer. Okay? And we're just going to run that. And that we have products owner in where clause. Where products, because it's product owner. Okay. So now we've got 4 products from this developer. Okay, so now we want to know the name of those apps, right? Well, the name is actually in the products description table. Okay, so I can't just do the product's name is called products name. Okay, which is found in the products description table, not the products table. Okay, so I only have the products table. I don't have the products description table. So we need to get it. In order to get it, we're going to do something called a left join. Okay, and a left join basically says, okay, what field on this table that I currently have, which is called products ID, matches the field on products descriptions. These two fields match. And what a left join will do is it will take this row. Okay, so let's flip over to here. Let's say products ID 120 is what we want. It'll take every column in here and bring it together with every column on here. Okay, so it'll bring all those together. It'll join all those columns together and give you all those results. Now, you can see that there's a problem if we have the same thing. So there's products ID here. There's also products ID here. So how does it know which one to get? Which is why we're going to have an error in a second. But in order to do the left join, what we're going to do is we're going to say from products, left join, products underscore description. Okay. Now we're going to join on what field are we joining on, because we have to tell it, and that's going to be the products description table dot products ID, and that's going to be equal to products dot products ID. Okay, that's the join. So if we run this, okay, we get an error called products ID is ambiguous, and that's because both products and product description both have the field products ID, so it does not know which one to pick. So we have to do it by putting the table name and a dot in front of it. Okay, and then this is going to be that guy. Okay, you could do either one, so this will work. Okay, so this works great. You could, because they both have it, you could switch products to products description right here. Okay, it does not matter They both work just fine, okay, because they both have it. But now we're telling it which one to get. Again, similarly, we shouldn't be writing products owner here. It's not ambiguous, but it's good practice to not do that, okay? So just always put the table name in front of it, okay? It doesn't need to be there, but we're putting it there anyway. So let's talk about how to get the view count. Well, the view count is literally just a table on the products description table. So I'm just going to copy that over from my good query and just put that in here, and that will now give us an error because I ended it with a comma and I shouldn't have. Okay, so there we go. Now we've got our products view. Nothing special there. So let's learn how to count. Okay, so we want to count orders underscore products. Okay, so basically what we want to know with this count is we want to know how many downloads a particular app has. So if we go to our orders products table, okay, a single line item is one download. Okay, so we're going to get all the items that have this particular product ID. That's going to give us all these results, and we want to count how many there are that have this. Okay, but before we can use this table, we have to join on this table. So we're going to do another left join on the orders underscore products table. Okay, okay, and now how do we want to join? Well, both columns have a products ID. So we're going to do orders underscore products dot products ID, and that's going to be equal to, again, we have two tables now that have products ID. We can use either one. Products is shorter to write, so I'll write products dot products ID. Now, when we do this, it's going to join, and it's actually going to bring us every single row because it can join. When it joins, it's going to get all these matches, which is going to mess up our data set, because if I do this, look at this. We've got tons and tons and tons and tons of that kind of data. So to fix that, we're going to use a SQL command called group by. So what we have is we have 153, 153, 153, 153, 153, 153. So we want to group by this number. Okay, we don't want to see that. Okay, so we're going to say group by products dot products ID. Okay, and that's going to bring them together and do that. Now imagine that all those are still here, and we can actually count those. So if we come up to our SQL statement, we can do something called count, okay? And what we want to count is, from that table, orders underscore products, dot, we want to count all the products IDs, okay? And this is going to happen before it groups them all together, okay? Because it's earlier in the SQL, it's going to do this before it brings them together as one. So that means all those results will still be there, so we can count them. So products ID, okay? And if we run that, it says count, so it was able to count how many of each there were. Again, we don't want it to call it count, we want to call it as, download count, okay? And run that. So now, download count equals all these. So you understand why this happened. When we joined on this, it gave us all those results, okay? So we grouped by the product ID, which was the thing that was being repeated, that sifted them all together and only showed us one of each. Okay, but before we did that, we counted how many of each there were. Okay, so now let's learn a summation, which is a little bit different. So the next thing we want to do is we want to basically find out the total cost. So to do that, we're going to go to our orders products table and look at our content. We've got a final price. Okay, so if we get all of these, just like we did, same exact thing, we're going to get all of these. Okay, to find out how much was made off of all of these, okay, we're just going to combine all the prices together. So all these are 0, but if we come down to something that's not 0, like this guy right here. So these are all these 153s. All of these right here are the 153s. To get how much was made in total off of this one app, obviously we would add all these numbers together. Okay, that's how you figure out how much was made out of all of these. Okay, so we can do that just like we did the count, only we're going to do the sum. So sum orders underscore products dot final price, okay, and that's going to be as revenue, we'll call it. Okay, we run that, so that adds up how much. It basically adds up all those together for that particular app. And again, we're not seeing them all because we're doing the group by. The last complicated thing we're going to do is do a count distinct. Okay, now why are we doing count distinct? So what we want to figure out is who bought what app. So to figure that out, we actually need the orders table, which is, if I could spell correctly, we need the orders table because there's the customer on the orders table. So we need to know who bought it. Okay, so if we go back to our query and we write, if we do a count, uh, if we do count order, well, actually, first and foremost, we can't use the orders table until we have the orders table. So all we have is products, product descriptions, and orders products. So we need to do a left join orders on. Okay, and to do that, we know that the orders products table has the order ID that it came from. So orders underscore products dot orders ID equals orders dot orders ID. And where am I getting that from? Well, I know that on the orders table, here's orders ID, and on the orders products table, here's the orders ID. Okay, that's what I'm joining on. So once we do that, let's run this. Okay, and it says we have an error because I probably okay, so there shouldn't be that comma there again. So now I run that. So we're okay right now. Everything's fine. The problem that we have is that, well, that's not a problem. Now that we've got our orders table, which is great, now we want to count our customers. So we can say count. Okay, so count orders dot customers ID. Okay, and we're going to say as customers. And we run that, and that gives us our customers. Now, why are these statistics misleading? Because a customer can buy an app multiple times. Okay, we're already doing group by the products. So now we have multiple customers in each result. So to actually amend that, you can actually select distinct customers, as in it's going to count all the orders customers, but only count the ones that are different from each other. Okay, and that's really what a developer wants to know. So we're going to say count distinct, and that's another SQL call, count distinct. And take a look at these numbers. We have 1426, 180, and if I run this again, those numbers go down dramatically. And that's because we had multiple people, multiple of the same person, buy the app multiple times. And we don't want those statistics. We want to only know who bought what separately. Okay? So there you go. That's how you do selects and counts and sums and count distincts, as well as left joins and group by. Again, if I didn't mention, the reason we're doing left join and not join is because left join leaves empty results in case they were there. Okay, so see how revenue is null right here? If I were to get rid of, I think if I were to get rid of and make them all joins, if any of the fields are null, then they won't join. So if I do that and run it, you can see that that field is now gone because join ignores when a field is null. That's why we want left join, because we want to know when a field was null. We don't care, we don't want it to go away, we want to know it. So we use left join and not join, and that gives us our empty result. So there you go, complicated SQL queries.